Okay, so welcome to the second workshop on vision-based industrial inspection. My name is Xu Li. I'm a machine learning engineer from Apple. So today I will be the moderator of this workshop and welcome everyone to join this morning session. So let's quickly go through today's agenda. We will have a brief opening from Shahari, who is the Senior Director of Apple. And then we will have another 3 keynote speaks from Professor Colomiso, from Professor Tsung, and from Dr. Vamula Pali. And after that, we will have 5 oral paper presentation. Then we'll have around 15 minutes coffee break, but as we have delayed 10 minutes, maybe the break will be shorter than expected. And then we will have a panel discussion hosted by Professor Simbis. And in the last, we will have some presentations from our data challenge, and we will announce the data challenge winners. So before start, I will like to thank you all the organizers of this workshop. We cannot make it without everyone's help. So we have organizers from the enterprises and from the academia. So thank you for everyone. Yeah, and hope everyone can enjoy this ECCV at Milan. And then I will invite Shahari to give us an opening remark.
Thank you. Can you guys hear me? Great. Well, welcome everyone. Thank you. It's great to see everyone out so early this morning. We are really excited to welcome you to the Vision Workshop. This is an exciting time for manufacturing. The industry is going through some seismic changes, and you all are at the leading edge. So here we have people from academia, from technology suppliers, and from original equipment manufacturers. And this is exactly the right blend to enable this transformation. So today, I'm going to quickly go through and provide a little bit of background on manufacturing. And then we're going to dive into where AI and ML come in. And we're also going to talk about some opportunities and challenges and say a little bit about the future. So first, a little bit about myself. I've been at Apple for 23 years. I have managed different teams in quality and test engineering, purchasing and designing capital equipment, and the new product design process. And in this role, I've also set up processes for Apple and systems as well. So today we're going to talk about the future of computer vision and automation in manufacturing, and some significant opportunities and challenges that we're facing right now. So first, before we get started, I'm going to do a very basic introduction of the supply chain, which I'm sure all of you guys are aware of, but we'll go through it quickly. So, first, basically, the world is very connected, especially when it comes to supply chains. So we start off the supply chain with raw materials that come into our factories. And these basic materials are made into basic parts, as you know, machined parts like enclosures or rolls of aluminum or chemicals. And then component manufacturers will use these to make basic components, which are something like resistors or capacitors. And then those will get assembled into modules. And these modules are the building blocks of more complex assemblies. So these are things like Wi-Fi modules or displays, camera modules, and so on. And then, of course, designers, original equipment designers will incorporate these into consumer products. And those are the products that we all enjoy. And then, of course, we design the repair supply chain as well. And this same set of supply chain nodes exists for all products. So our problem statement is very general. And as you can see, there's more and more value that's being added at every node of the supply chain. So let's take a quick look at what a production line looks like, and they all follow more or less the same pattern. You have incoming inspection, which is basically making sure that whatever parts you're getting are going to be exactly what meets the specifications that you purchased. And that could be functional specifications, which are tested, or mechanical or dimensional test specifications. Then you have the production itself. That is where the product gets transformed into whatever you're making. That's the value add part of the process. Steps 3 and 4 are test and inspection. And these are basically verification steps. So this is basically the point at which the test equipment is used, lots and lots of data is generated, or there's some inspection process that makes you make sure that we are meeting the visual spec that we're trying to hit for this product. And then, of course, everything is packed and shipped to the customer. So the very rough outline of manufacturing process, it's going to be the same set of processes that take place in all nodes of the supply chain that we talked about earlier. Okay, so now, just like everything else is changing in manufacturing. So incoming inspections are no longer measured by hand. Images are taken, characteristics are calculated, and the production is automated. And similarly, assembly is also automated. And so you have a lot of images that are being taken, hundreds of cameras on the production line, and then those are using datums to assemble the product. Test generates millions of data points. And of course, visual inspection is the high value problem that we're waiting for all of you to solve. And of course, pack and ship. So how does AI ML help in this situation? And why do we need it? So we believe that quality and consistency when it comes to repetitive tasks are best done by ML. Also, we're able to eliminate redundancy. So in this vast supply chain, we don't want to waste effort redoing things, retesting, and reconfirming that a part is good. We want to be efficient with cost and effort. And since we're in a CV conference, I take the example of inspection. People inspect product at every node of this vast supply chain. So the intuitive use case for us is to use camera plus machine learning to inspect. And that would mean everything from the manufacturing of everything from toilet paper to cars can be inspected consistently with machine learning integrated into the back-end systems. And then we would also have the ability to detect failures, to categorize them, and then to understand how that particular defect came about through having data and models to suggest how to fix it in the long run. So with this kind of a system, what you will be able to do is within seconds be able to analyze the failures you found and match it against corrective actions and root causes. And as soon as a new failure mode crops up, we can also detect that this is something new and perhaps previously proposed solutions will not work, and we actually have to investigate this particular failure mode. But if you look any further, you will realize that you need to get a high level of accuracy. So to automate this system. So accuracy over 99% is required because you're manufacturing millions of devices per day. So anything less than 99% accuracy is going to slow down your factory. Manufacturing also has a lot of refresh cycles. Products change frequently. And when a device changes and the model still needs to perform well, that becomes a domain transfer or a generalization problem. So that's the next level, is that we do need to be able to transfer and generalize problems. And that should be very familiar to everyone who participated in the data challenge workshop. Other technical challenges include the ability to be to refresh your models very, very quickly, to keep up with all the new parts that come in and all the new products that change every 4 to 6 months. And that really translates to the speed of model creation, validation, and deployment. And of course, creating platforms, creating systems to create annotations very easily. Those are all the things that need to go along with being able to refresh really fast. And then finally, we need interpretable systems. So that means that it's not just a machine learning engineer who has to be able to interpret the results, but the worker on the production line needs to understand why the machine learning model has a failure. Okay. So what are some good solutions in this space? So we believe that better technology is going to be one key enabler that's going to help. We're going to be able to have, or we're going to have to build up defect libraries, synthetic images, clear annotations to reduce time to be able to change models over. We also really believe in the engagement of the workforce. That is enabling manufacturing engineers and production line workers to participate in the refresh effort. So we want them to help to refresh the models. And we believe that this on-the-job training is one of the best ways to engage working adults in the world of AI and ML. Finally, reduction of waste. When we want to reduce waste of time, of human effort, of materials, we have this huge supply chain, and at each node in the supply chain, you're basically doing the same work over and over again. But what happens if you're able to take the data from one node and move it to the other? Can we predict the quality issues that happen upstream, inform suppliers further downstream? What happens if we're able to forego some of the test processes that are non-value add in order to be more efficient? So these are the solutions that we think are going to be the promise of creating something better in manufacturing going forward. Okay. And so with that, I'll end with some thoughts on what manufacturing will look like in a few years from now. So up until now, we've emphasized a very standardized production line. So we have very consistent, uniform lines. Every single device goes through the same manufacturing process. Everything from potato chips to coat hangers follows the same process. It's standardized input and standardized output. But with new technology, what we see is that data from one node of the supply chain can actually be moved and transferred to another node. And images can be analyzed, and quality can be predicted by combining dimensional data, categorical data, and getting that data from all nodes of the supply chain and really actioning them real time. So can these algorithms running across the supply chain predict issues and also optimize the supply chain real time? So with that, we're so excited to have you guys join this summit, and we look forward to hearing more from everyone. Thank you so much.